Welcome to the second part in the topic programming constructs, and we want to look at arithmetic operators. Now, I want us to start by looking at what is an operator. An operator is a symbol which helps the user to command the computer to do a certain mathematical or logical manipulation. Okay, so you may want to add two numbers, you may want to subtract them. So for you to add them, you will need a plus operator. Okay, so that is what you call an operator. A symbol, it can be a plus, a minus, a symbol which helps the user to command the computer to do a certain mathematical or logical manipulation. Now, operators are used in programming language to instruct or to write instructions on how a program can perform a certain operation on data or values supplied to variables. And it is also important to be aware of the fact that operators don't just come in one type, they're in different categories. They are what are known as arithmetic operators, relational operators, logical operators, increments, and decrement operators. Now, let us see what each of these are, starting with the arithmetic operators. Now, you can use an arithmetic operator with one or two arguments to add, subtract, multiply, and divide numeric values. Okay, so you can have an argument on one side and another argument, and the operator performs what that operator represents. So, for example, if it is a plus, well, it means it's addition which will be performed, meaning two or more values will be added. The minus symbol is for subtraction, the star symbol is for multiplication, and this slash is for division, and this, what looks like a percent sign, is for modulus, meaning it takes account of remainders, numbers which remain after a division has been done. So if I say 10 modulus 2, what I mean is what will be the remainder if 10 is divided by 2, and obviously the answer is 0 because 10 divided by 2 is 5 with 0 as a remainder. Now, there are different ways in which these mathematical operators are used, and you could be well acquainted with these. 5 plus 3 equals 8, 5 minus 3 equals 2, 5 times 3 is 15, 5 divided by 3 equals 1, then 5 modulus 3 equals 2, because when you divide 5 by 3, it is 1, and the remainder which remains is 2. Okay, so now the other thing I need to mention is this star symbol for multiplication, the division symbol, or the modulus will be performed before plus or minus in any expression, so they are given a higher precedence. So whenever you have a mathematical expression where there is a, for example, there is a multiplication and there's addition, so the multiplication will be done first. But sometimes if we want to force our own sequencing of how the operation has to be done, we can use brackets. So brackets can be used to force a different order of evaluation to this. Now let us talk about relational operators. A relational operator compares two values. Okay, so for example, y is greater than 8. That simply means the value in y is greater than 8. So, and now the thing is, we do not know what this y represents. Suppose it is 2. Is it true that 2 is greater than 8? So what you see here is that this expression will have a value which culminates to true or false. Okay. Now, relational operators are sometimes called comparison operators, well, simply because you use them to compare two different expressions of values, and expressions that contain relational operators are called relational expressions. A simple relational expression contains only one relational operator and takes the following form. So if you have expression 1, then you have a relational operator here, then expression 2. So where exp1 and exp2 are expressions which may be simple, constants, variables, or combination of them. Now, these are the different relation operators which are there. This operator is for less than, this is for less than or equal to, and this is for greater than or equal to, and this is for equals. Now, a common mistake most students make, they read what we normally refer to as the, let me pick a pen here. I want to illustrate something. I want to talk something about this equal to. So in programming, this is not equals to. This is an assignment operator. It's an assignment operator. But where you want to write the equals sign, you use this. This is what equals. It's what we use to represent equals. Then not equal to, we represent it by an exclamation mark and then with the equals sign. Okay, fine. Now let us look at some examples. If x equals 2 and y equals 5, so let us look at this expression here. So if x equals 2, so that means if x is 2 and y is 5, will this evaluate to true? So let us replace them by numbers. 2 and this will be 5. Is 2 less than 5? Yes, this is true. So, and here we have true. Okay, so you can work out, these are the expressions. Let me pick the last one here just for an additional example. Y is 5, so I'll put 5 where there's y here. I'll put 5. And here it says 5 is greater than, in the brackets, 3 plus x. X is 2. 3. So this is 3 plus 2, which is 5. Now, is it true that 5 is greater than 5? No, this is false. And that is why here what you are seeing is that. Okay. Let us move on to logical operators. A logical operator is a symbol or word used to connect two or more expressions such that the value of the compound expression produced depends only on that of the original expressions and on the meaning of the operator. Let us unpack this. What do we mean by this? Now, there are three logical operators, the and, the or, the not. These are the basic ones. And starting with the logical and, with this operator, if both the expressions to the left and to the right of the logical operator is true, then the whole compound expression is true. So, if let's look at the examples which have been given. So, for example, if expression 1 is false, expression 2 is false, then ultimately the end result will be false. If one of the expressions is true and the other one is sorry, what we're looking at here is logical and. I thought I was looking at the or operator. Okay, so with the and operator, if you have false, then the end result is false. If one is true, the other one is false, the end result will be false. If one is false, the other one is true, it's false. If one is true and true, then the end result is true. And actually, this can be expressed mathematically in terms of, by using multiplication. So false. Let me represent false by 0. So what is 0 times 0? 0 times 0 is 0. So false times false is false. Suppose we have 1 meaning true, times false. I'll represent it by 0. What is 1 times 0? It is 0, and that is why here true and false gives false. Well, suppose I say it's 0 times 1, meaning false and true. Still the same, it will be 0. But suppose it is true and true, the end result will be true. So you can see the AND operator is an equivalent of the multiplication operator. Okay, and now let us look at this. By the way, in programming, usually 2 ampersands is what we use to represent the AND operator. So now if A equals 2, B equals 3, C equals 5, let us look at this expression. So this expression will be 2 is greater than 3. And C is not equals 5. C is not equals 5. And we know that C is 5, but here we're told C is not equals 5. Now, if you look at this, this is a false. 2 is not greater than 3. Again, when you say 5 is not equals 5, this is false. So this whole expression amounts to a false expression ultimately. Okay? You can work out these others. You can pause the video, work out these others, and see what results they'll give you. Well, these are the results you should see. Okay, now let's move on. Let us look at the logical OR. The logical OR is used to combine 2 expressions, or the condition evaluates to true if any one of the 2 expressions is true. So if any of the expressions is true, then, well, then ultimately the whole expression becomes true. And this is equivalent to the addition operator. So for example, here you have false and false. Remember, false will be represented by 0. So what is 0 plus 0? Okay, let me just one. So 0 plus 0, well, equals 0. So if it's false and false, it's false. Then here is true plus false. So this is 1 plus 0. And what will be the result? It will be 1. And well, with binary addition, we know that 1 plus 1, in this case, we make an exception here. I don't want to go into what is the details of what is known as an exclusive or inclusive OR, but the simple rule here is if both statements are true, then the end result is true, which is 1. Okay, but there is a topic where we'll look at the 2 different types of OR, where 1 plus 1 can lead to a 0, meaning a false expression. Okay, but that's not our focus for now. So, but suffice to say that this is the basic OR. Okay, now we have an expression here as an example. If A is less than M or A is less than N, the expression evaluates to true if any one of them is true or if both of them are true. So following the rules we're just from talking about. Let us look at an example. Let us pick on this first one here. So if A equals 2, B equals 3, C equals 5, so let's replace these variables. A is 2, so we're going to have 2 greater than 3. Okay, that's what we have there. Or C, which is 5, not equals 5. Now you know that 2 is not greater than 3. This is false. It's a 0. Here again, this is false. So remember, with the OR, 0 plus 0, the result is 0, so it's false. Okay, so you can try out these others, but the whole idea is with the OR operator, if one of the expressions is true, then the end result is true. Okay. Now, there is also what is known as the logical NOT. Okay. The NOT expression evaluates to true only if the value of x is neither greater than or equal to y in this given expression. Okay, so logical NOT, it negates, okay, it gives the opposite of a given value. So for example, let's look at this. This, we are told, if we are told not a greater than b, okay, so a is 2, b is 3. So this expression here, we know that it's false. Now when we say not false, it means we want the opposite of this, and it means it will give a result of true. So with the not expression, it negates whatever statement is given. Okay, so for example, let's look at b. B will be 2 is less than 3. Is this true? Yeah, it is true. Now when we say not this, what we're saying is the negation of this, and it means the end result will be a false, and that's what you see here. Okay, I hope that makes it clear. So you may want to know how these different operators are represented in different programming languages, programming language syntax. There's a video which teaches on the syntax. We'll look at it in the other sessions. But in C++, the AND operator is represented by 2 ampersands, the OR operator by these 2 lines, not by this exclamation. So you notice that all these programming languages, C++, C#, Java, JavaScript, even Swift, they all have the same syntax on this, except Python. Python has a very simplified syntax. It actually uses the very words and, or, and not. Okay. Now, finally, let's talk about increment and decrement. What operators are these? These are operators which increase a given value by 1 step. So the increment operator, for example, represented by 2 plus signs, adds the value 1 to the current value of operand. And then the decrement operator does that, the opposite of that. It subtracts the value 1 from the current value of operand. So if the variable x has 5 in it, if I write x plus plus, it simply means x plus 1, meaning 5 plus 1, which will be 6. Likewise, if I use the decrement operator, x equals 5, if I write x minus minus, it means x minus 1, which will be 4. May I also point out that this can be written the other way around. You may write it like this, x plus plus, or you can start with the operator signs and then write x, or still the same thing. Well, that's about arithmetic operators.